Triple your pattern making in 3 easy steps. Step 1 is scan, step 2, convert to CAD, and step 3, flatten 3D to 2D. This is ExactFlat Scan to Pattern, and we'll show you how. Okay, hi, this is Ethan Donald from ExactFlat. I'm the CEO of ExactFlat, and I'm here with Peter Warburton from Creaform, and we are going to be demonstrating how to use the Peel 3D scanner for upholstered furniture. Peter, what is the first step in the process for scanning an object like this?
Okay, this object, our scanner can scan on 3 things: texture, color, if you like, geometry, which if it has geometry, and it can also scan on targets. Now, geometry doesn't, it has to be a reasonable amount of interesting geometry. So if I try and scan, say, a soccer ball, it's perfectly round, it looks the same for any direction. I could probably scan this without targets, but honestly, your life will be so much easier if you do it with targets, that why bother? So we're going to put targets on this chair.
So Peter, then you said the geometry. So because we have like sort of flat, undifferentiated surface, this is where we need to break the surface up, and that's where the targets come in. Is that correct?
Yeah, well, there's no geometry to be seen there. It can't tell if it's moved in this direction or this direction because it's flat. So yes, targets tell it where you're looking at this chair from, and that enables it to keep track, which is what we used on the wheel hub earlier. Okay. It's same technique.
So this, even though this is a piece of furniture, this would apply to automotive, this would apply to insulation covers, this would apply to any type of object that's going to be covered in fabric. So what's the process for putting the targets on? Is there some sort of criteria that we need to follow?
Yeah, pretty much. First of all, they have to be random, which is great because humans can't put things in lines, so it's automatically random if you put them on. There were 2 boxes of targets in your box when you unpacked it, and basically the rule of thumb is about 4 under a handspan. So I'll show you the sort of thing you do. The box actually has a neat little technique where you pull the tape and it dispenses targets. So this is a sort of typical target spacing, and so it's going to take a little while to do this chair. I should point out that you shouldn't put targets on high curvature edges, and you shouldn't put them near to the edge of something. There's not really an edge here, but the scanner needs a couple of millimeters around each target. So don't put them right on the edge of a table or something like that. It won't work.
So you would not recommend on these seam lines or these edges here, or
don't put
here?
Don't put them on the seam lines because you're going to want to pick those seam lines later in the software. So all it is to help the scanner keep track of things, and that's about the density of points. In fact, you could probably get away with a few less, but we're going to cover the chair and get back to you. So now we're going to have my assistant, Pierre, to do the scanning for us while Ethan and I discuss the techniques used in the scanning. So off we go. We'll start on an easy bit. That's light colored. The automatic shutter is in use, so it's adjusting the shutter itself, and you can see the speed at which it's acquiring the surface. It's pretty fast, and we're not using texture because we don't need it. And as you can see,
and it doesn't have to be exact either, because I see he's kind of reaching to reach the top there.
Yeah.
Like there's a variable range of distance which is acceptable to pick up the scan?
Yeah, it's about 30 centimeters plus or minus 10. Okay. And as I say, keep an eye on that bar. If you're too close, it will tell you, and if you're too far, it will tell you. And in fact, there's also lights on the back of the scanner that do the same thing. If it's green, it's good. If it's red, you're too close. So there's a couple of ways of looking at the distance you are from the object.
Okay, but I have a question. So I see some of the targets, like this one right here, is not exactly flat. It's kind of raised up a little bit. This one right here is raised up a little bit. So is the scan going to accommodate for that and assume it's a flat surface, or is it going to pick the target?
It's going to assume it's a flat surface and fill it in, but it's going to fill it in at the level of the target. So you should try and just push down the target when you apply them, make sure they're stuck. And as I said when we were unboxing, there is a box of very sticky targets, there's a box of ordinary sticky targets. On something like this, which is loose, felty, you should probably use the high stick targets so that they don't pop off. And try not to put them on high radius curves because that will make them pop off. Yeah.
Okay.
I'm just going to scan the target surface. I'm just going to switch to the shutter time a little bit higher.
Yeah. When you're trying to scan something that is both black and white, like this chair, the automatic shutter is probably going to be fooled. And there you can go to, while you're scanning, in fact, you can go to manual shutter and adjust the shutter speed. So now he's jacked up the shutter speed, which you can see in the bottom right of the screen, and it's now acquiring fine the black part of this fabric. So this is what you do if you had a motorcycle seat or something like this in multiple colors or very different shade. You go to manual shutter. And you're always free to play with it. It doesn't make any, it's not going to ruin the scan for you.
So you can adjust to manual shutter halfway through the scanning process?
Yes, you can. And back to automatic.
So if it's not, say, for example, like, more of a dark black and white, say it's like a brown or something, and you need to, you can try scanning it, and if it doesn't work well, you can just scan right over top of that with the manual shutter?
Yes, you could. You'll see if it's not acquiring any surface when you're over it at the right distance, it's probably a shutter problem, and you should go and adjust the shutter.
So you'll get immediate feedback on that?
Yeah. Noticing that, Now you can see that Pierre's having to reach to get to the top of this chair. Because the targets are on the chair, we can actually just tip it over and get to bits that he can't reach. And you can see the great thing about this one is we can turn it around. But otherwise you're going to have to be walking around this chair. Have you got the top? Do you?
No, we could do it.
Okay, well, just taking care not to move any targets. We'll just drop it down a bit. It doesn't have to be stable. Are you okay? Or we'll put it on the side?
Yeah, well, I will just
drop it down all the way? Okay.
Yeah, do this.
And then you can complete the parts that you couldn't reach before.
And if it moves a little bit, like I'm not
That's
holding it perfectly stable, that's okay?
Watch this. Doesn't make any difference because of those targets. So it's immune to vibration. What it mustn't do is change its own shape. So if you were trying to scan my arm and then I did this, that wouldn't work.
Right.
But this is
so the relative geometry must stay consistent, not
Yes.
necessarily the position of it then.
That's it. That's exactly it.
Okay, so if you are scanning somebody's arm, you would have to tell them to hold still or get them to rest it some way,
Yeah.
and then they would scan, but
Yeah.
they couldn't move it.
Well,
in
because
any way.
you're creating two different models.
Right.
Yeah. Actually, this is really useful, this turntable.
Well, I would expect that if you're doing a lot of scanning, you would set up your scanning environment so that you have all these
Absolutely.
workflow time savers, right? Like you'd put it on a turntable, you'd mount it at a height that made sure you didn't have to reach
Yeah.
or bend over too much or that type of thing. Or if you had to flip it over, you could do that. So for, depending on what your application is, depending what the scanning is, you'd set your workflow up. And this has actually had zero effort in workflow. We just kind of plopped it on the table and started scanning, and it's still going pretty quickly.
Yeah, it scans really fast. It takes a little while to put on the targets, and you're going to want to remove them at the end. But make sure check your scan before you remove the targets, because once you remove the targets, it's more difficult to go back and complete anything that you've missed.
Okay, so I'm already finished, just filling up some remaining holes.
So I do have a question then. This is where the seam locations of the upholstered fabric cover would go.
Yeah.
And I noticed that he's doing a scan in a particular mode here. How would you pick up these locations so that you could have an accurate representation of where you want those cut lines to be?
Well, you will see them in the mesh.
You'll see them in the mesh.
Oh yeah,
okay.
that's enough to be seen in the mesh. If it's not, then you maybe need to acquire texture. If, for instance, it's a continuous fabric, but it's a different color, and you want to cut on that, then you should be acquiring texture as well.
Okay.
but that will take you a bit more time. So this is enough to, we'll have a look at the mesh afterwards, but now that's quite a lot of triangles we've just acquired, so there's a little bit of time to post-process it. Are we done? Have you stopped?
Yeah, I just stopped the scan.
Okay,
right
so
now.
okay, that's the post-processing time. It's taking the mesh that it was showing you and actually perfecting it from all the images it took.
So this is the conversion from a point cloud to a mesh. Is that what's happening right now?
Yes, except it's already building the mesh when it's scanning. It's just refining it. We don't actually work with point clouds.
Okay.
It's making the mesh as it scans. Okay, so if you want to zoom in on that seam and just check that we can see it on, say, the left arm or the right arm. Yeah, you can see that seam. It's not perfect. We are showing it at 2mm resolution right now.
Oh.
Yeah, it's okay. That's enough to pick. I think that's enough to pick your shape. Is it okay for you?
I would say it is.
Yeah.
So you mentioned 2mm resolution. Can you just talk a little bit about resolution, high
Okay.
versus low, and sort of optimal?
Pierre's going to turn on the mesh, and I'm going to show you the mesh that's associated with that surface. And we're going to zoom in because it's a lot of. Okay, those are all the triangles. Keep zooming, keep zooming. So that's your mesh.
So it's a very dense mesh.
It's a very dense mesh. In fact, you don't need it that dense.
No.
So there's a couple of things you can do. You can. That's 2mm. So don't go setting your scanner to
So
1mm.
the
You
resolution
don't
you're
need
talking about is the polygons on the mesh.
Yes.
Not necessarily
the
the
mesh resolution.
mesh resolution. Okay.
Not the accuracy.
Right.
They're two different things.
So-
the accuracy is 0.1mm.
Okay.
The resolution is what you need it to be, and honestly, that's plenty. In fact, it's overkill. And I'll show you later how to decimate that mesh to make a file size. Can you show us the triangle count on this chair? Yeah. So down on the,
Nearly a million.
how many? A million.
Yeah, nearly 9,000.
Okay, so there's
900,000.
nearly a million triangles on this chair. It's not got any intense geometry on it, so you in fact could describe this chair perfectly with 100,000 triangles.
Or we would even
Tenth
say
of that.
less.
Or even less.
Even less. Because it's
And-
flat surfaces. For the most
And you
part.
don't want to be pumping a great big mesh into ExactFlat, giving it indigestion for no reason at all. So we will show you later how to decimate that mesh down to a reasonable level and still maintain accuracy, because we have a function that will make it put big triangles where it's flat and small triangles where there's details. It's the equivalent of JPG in a picture. It's compression, but without losing any accuracy. So we'll show you that later on. But what I'm showing here is that you do not need to scan at 1mm. 2mm is plenty. You could probably scan at 4 on something like this and still be fine.
And so that's just a matter of finding out what works for you.
Yeah.
Because this is a balance of resolution and accurate results, but also time. You don't want to have to take too much time to do this, right? I mean,
Yeah.
So I'm assuming that the higher resolution meshes cause processing overhead and a
Absolutely.
bunch of things that to sort of complicate
Yeah.
your workflow.
Mhm.
So you want to get this to be optimal, and that's just a matter of scanning at a high resolution, the middle, and the low, and then seeing what works.
Yeah.
Is that, and
Absolutely.
that's part of your first introduction to the scanning process. I
Yeah,
suppose.
when you get the feel for it, you'll know that you don't need to scan it at 1mm. But,
Right.
if you're doing something detailed, you might. But
Because this might be a common mistake. Higher resolution would be, I guess, universally seen as better.
yes,
But that
and
is
it's
not the case. Okay.
Yeah, absolutely not. And indeed, if you're getting to 5 million triangle counts on your computer, you're probably sucking up a load of RAM. You're slowing it down, and it will almost certainly be difficult to use in other software because it's just such a big file. So
Okay. So we don't want to make this seem complicated. It's a process of just getting to know the scanning, like the scanner, and how to scan, and setting it up properly, and then it's done. You don't really have to go through this
absolutely.
sort of like decision making
Yeah.
in subsequent attempts.
Yeah.
You also have to look what you're looking for. So I've got some holes in the scan. You get to ask yourself, do I need those data? We've got a fill hole algorithm that we can use later. But if it's really detailed that you want to have, you can always go back, because I'm missing some spot. I can always go back and go scanning if I would like to have more show you. So that's an option that could be done as well.
And I just want to point out, even though the scanner is picking up what may be considered undesired artifacts, like for example these wrinkles right here and these wrinkles right here, those things can easily be accommodated when you go into the flattening process. So those are not, you need not worry about that. You'll still get very smooth surfaces that when you actually upholster the chair, they'll fit perfectly.
Yeah, it's capturing reality. So if there's wrinkles, it will capture the wrinkles.
Yes.
This concludes part 1 on how to scan your part. In the next section, we cover how to convert your scan to 3D CAD. It's part of our video series on how to triple your pattern making in 3 easy steps using ExactFlat Scan to Pattern. It's the faster, better, cheaper, and easier way to create patterns for all your products. Be sure to check out our next video. You can also contact us at your convenience for a demo or to learn more. We'll show you how.